Alright, today what I'm going to be doing as your host, JD, I'm going to show you how to do this system of equations with Cramer's rule. So if you would, pause the video and see if you can try this on your own. Alright, you should have noticed that I kind of was a little nasty with it. I didn't set it up like how you would normally set it up when you do Cramer's rule. What you want to do when you set up using Cramer's rule is you want to first put it in standard form. Make sure both of them are in standard form. This one is not in standard form, so you have to change it. You can either bring this over to this side. I know it's not supposed to be negative in standard form, but as long as you get it like standard form when you're doing Cramer's rule, it doesn't really matter. So that would be negative 2x plus y equals 7. Now you can apply Cramer's rule. Cramer's rule, you're using the determinants of matrices. Now what's going to go in here on the top are the x's and solutions. Well, let me put it this way. Your normal is going to be 2, negative 3, and then you have negative 2, 1. So on the top, it's going to be just like this, but your x's are going to be the solutions. So negative 13 and 7 take over that x, and then negative 3 and 1, it kind of stays the same. Now for your y's, let me set them up first. For your y's, it's going to be pretty much the same. The denominator is the same. It's just the coefficients of the x's, right, in standard form or semi-standard form, and the coefficients of the y's. So this is going to be 2, negative 2, and then negative 3, and then 1. Now for the matrix on the top, same pattern. You take this, and whatever you're solving for, that's what you want to replace. So here you're solving for the y's, so you want to replace these, the negative 3 and the 1. So negative 13 and 7, and then this is going to be 2 and negative 2. That's where we are. And so then you just solve it and you simplify. Let me put a divider in there. To simplify this, you just take this 1 times negative 13. That is negative 13. This 7 times negative 3 is, it's going to be a negative 21, but since it's down up, it negates it and makes it a plus 21. What's negative 13 plus 21? Yeah, it's going to be a positive 8. Now you do the same thing with the denominator. 2 times 1 is 2, and then negative 2 times the negative 3 is what? Yeah, it's going to be a positive 6, but remember we're negating it. So since we're negating it, it's going to become a negative 6. What's 2 plus a negative 6? Yeah, negative 4. And what's 8 over negative 4? What's 8 over negative 4? Yeah, it's going to be a negative 2. Over here, you have 2, negative 2. I don't know if you can see that. And this is negative 13 and 7. So you do those. 2 times 7 is 14. Negative 2 times a negative 13 is a positive 26. But remember, you're negating it, so it becomes the opposite sign. It's a minus 26. And guess what? This denominator is the exact same thing. So I don't have to recalculate. So it's a negative 4. So I have negative 4. And what's 14 minus 26? What is 14 minus 26? Yeah, it's negative 12. And what's negative 12 over negative 4? Positive 3. So my x is negative 2, and my y is a positive 3. So your solution is a point negative 2, comma 3. Now what you can do is take this and plug it in. So if I take this and plug it in, I want to see if it's true or not. What's negative? Well, 2 times negative 2 is negative 4, and this is 9. Negative 4 minus 9, yes, that's true. Now, with this guy, I have, and you always want to plug it into the originals. Always plug it into original equations, because when you're simplifying or when you're adjusting things, moving things around and around, well, you might have done something like an algebraic mistake. Well, if you did an algebraic mistake, that's going to affect the problem. So you always want to plug them into the originals. If they're true in both cases, therefore it's a solution and your work is correct. Well, you know, otherwise what would happen? What's 2 times negative 2? Negative 4, right? Plus 7 gives you the positive 3. So since both of them are true, negative 2, comma 3 is your solution.